This is question B, part 9 of Seoul National University's Mathematics Aptitude test that was held in 2015, 10th of February. The reason I chose this question is because this is, as always, great practice for students who are studying calculus, and especially students who want to expand their knowledge over the syllabus of the IB course. So let's see where AK is defined as the integral from k pi to k plus 1 pi x sine x dx. Find this limit and sigma over here. This looks very horrible at start, but this might come to be not that bad. As the first thing we should see is that notice AK is a name for a sequential set. For example, A1, A2, A3 means in a sequence the first term, second term, third term, right? And therefore we can assume, well, not assume, know that AK, so K is a integer, positive integer as well. Zeroth term don't exist in sequence and series, as we know. And this term is defined by an integral. And on the bottom, if you see a limit and a sum, sigma together, then we should automatically think of an integral, because that is basically the definition when you divide small portions of the area and you add them all together, which is basically the definition of an integral. So let's hop right in. So AK is the integral from k pi to k plus 1 pi of x times sine x dx. So far, so good. So we can integrate this by using integration by parts. So if the integral of u dv equals uv minus the integral of v du. This is the reverse product rule. If you differentiate all of it, you get u dv plus v du equals the differentiation of uv, which is what we know. So here I will set u as x, and sine and dv as sine x, where we get du equals 1 and v as minus cosine of x. Then we find this integral to be uv, which is minus x times cosine x minus the integral of v times du, which is minus cosine of x dx. The minus minus comes out, so we get x times cosine of x plus the integral of cosine x, which is sine x. That's an indefinite integral, so we can rewrite this as x minus x, and there is a minus right here. That is my bad. So that is, as a definite integral, that would be sine x minus x times cosine x from k pi to k plus 1 pi. If you input this, we get, that's a big number. That's long. So sine of k plus 1 pi minus k plus 1 pi times cosine of k plus 1 pi. I'll continue under minus sine of k pi minus k pi times cosine of k pi, right? Now notice, because k is a positive integer, we can assume if we look at the signs first, the sign function, we can see that if k is a positive integer, sine of k plus 1 pi will be, when k is 1, it will be sine pi. I'll actually write this down. So this would be sine pi, sine 2 pi, sine, and so on. And we know that if the pi's increase by terms of pi's, if they're multiples of pi's, sine is equal to 0. So this all equals to 0. Same thing with sine of k pi, because when k is 1, it's sine pi, 2, 2 pi, 3, 3 pi, and so on. Sine of integer multiples of pi is 0. So we can simplify this as zeros and zeros. And here we know that cosine of k plus 1 pi is will be when k is 1. That will be cosine of pi. This is cosine of pi, cosine of 2 pi, cosine of 3 pi. So it starts as -1, and then it becomes 1, and then -1, and so forth, depending on k. Same thing for k pi, we get cosine of, it starts with 2 pi, right? 3 pi and 4 pi. So it goes like 1, -1, 1, so forth. For cosine of k pi, it would be cosine of pi, cosine of 2 pi, and cosine of 3 pi, and so on and so forth. Therefore, it will be -1, 1, -1, and so on. So we can rewrite the whole thing as 0 minus k plus 1 pi times cosine of k plus 1 pi is, well, -1 to the power of k plus 1, right? Because if k equals 1, it's -1 squared, which is +1, and then as k plus 1 is odd after that, and even, odd, even, it would traverse through the -1s and 1s. This minus the second half, which is 0 minus k pi times -1 to the kth power. Because k starts as 1, it would be, when k is 1, it would be -1. When k is 2, it would be -1 squared, which is +1, and so on and so forth. I'll simplify this, which happens to be, because the k plus 1 indice can be written as -1 times -1 to the k. We can actually multiply the minus in front over here to cancel out to get k plus 1 pi times -1 to the k, and then the minus cancels out, plus k pi times -1 to the k. Therefore, we can factorize the -1 to the k, well, pi -1 to the k, I guess. -1 to the k times pi, which will leave k plus 1 plus k, which is 2k plus 1. Beautiful. So this is a k. And now what we want to find is the limit as n approaches infinity of 1 over n squared times the sum from k equals 0 to n of -1 to the k times ak. So obviously we can rewrite this as the limit of n to infinity. I'll put the 1 over n squared. I actually won't. 1 over n squared, the sum of k equals 0 to n of -1 to the k times -1 to the k times pi times 2k plus 1. Now notice that we have a -1 to the k, two of them. So we can actually rewrite this as minus 1 to the k all squared. So whatever minus 1 to the k becomes, it's either minus 1 or positive 1. If you square it, it's basically like putting a modulus sign. It will always be positive 1. So they cancel out to become 1. So the question here is actually the limit of n approaching infinity of, I'll put the pi outside of the sum because that can be done with constants, pi over n squared times the sum from k equals 0 to n of 2k plus 1. This drastically makes our lives easier, and we can actually calculate, well, not calculate, but generalize this sum, because this is basically when k equals 0, this is 1, plus when k equals 1 is 3, plus 5, plus 7, plus so on. It's the addition of all odd numbers up until the number 2n plus 1. So how do we find the sum of this? Well, we know the Gaussian sum, which is n over 2 times u1 plus un, gives the sum to n terms. So we can find out that at n, it's at Sn is this. Therefore, Sn equals, in our case, n over 2, u1, which is 1, plus un, which is 2n plus 1. Therefore, we get 2n plus 2 over 2, which is n times n plus 1, which is n squared plus n. So we can rewrite the whole thing. So we're saying that this is Sn, therefore the sum from k equals 0 to n of 2k plus 1, right? So we can rewrite the whole limit as from limit n approaching to infinity of pi, and I'll put the pi outside the limit of this 1 over n squared times n squared plus n. Now obviously we can rewrite this as pi times the limit of n approaching infinity of 1 plus 1 over n. And we know that as n approaches infinity, 1 over some number approaching infinity is 0. So this is basically pi times 1 plus 0, which comes up to be pi. Therefore, this question's answer is pi. This question started drastically that looked drastically complicated, but ended up being not that bad. Thank you very much.